Let's talk a little bit about accuracy and precision of measurements in science. I know that the terms accuracy and precision are used interchangeably in general talk, but in science, they're two independent things, and it's worth talking about them independently. So let's talk about what those two things are. Accuracy is how close your measurements are to whatever the target or exact value, accepted value would be. If we're playing darts, accuracy would be how close are the darts that you throw to the bullseye. There's a target that we're supposed to be hitting. We're throwing the darts. How close are our darts to that bullseye? That's accuracy. If we talk about precision, we're not even considering the actual value. We're considering how close the measurements are to each other. So in our dart example, if we're throwing our darts and we're looking for precision, we don't care about the target. We want to know how close our individual darts are to each other. If we evaluate these pictures in terms of accuracy and precision, that might help a little bit. So let's go to the picture that is probably the easiest to deal with, the one that has high accuracy and high precision, and that is example number 4. If we look at number 4 and we look at those 4 darts right there in the center of the bullseye, we can evaluate them as high accuracy because all of those darts or measurements are in the target or very close to the targeted value, right? If we evaluate how close they are to each other or the precision, well, all 4 of those darts are sitting really close to each other in the bullseye. So for example 4, those darts are showing high accuracy and high precision. And that is the goal. High accuracy, high precision. Measurements that are repeatable and are always accurate or close to the targeted value. If we look at example 3 and we evaluate it in terms of accuracy and precision, we're going to say that those 4 darts are not accurate because they aren't close to the bullseye. So not accurate. But are they close to each other? Are they precise? Absolutely. So what this demonstrates is you can be precise but inaccurate in measurements. So which do you want to be if you can only be one? Would you rather be accurate? Would you rather be precise? I'm going to leave that question hang for a minute and come back to it. If we look at examples 1 and 2 and we evaluate those two in terms of accuracy and precision, it doesn't matter what we start with. I think that we can both agree that the darts in example 1 and the darts in example 2 are not accurate, right? Because they're not close to the bullseye. But if we evaluate them in terms of precision, now we've got some, I don't know's going on. Let's look at example 2. How close are those 4 darts to each other in example 2? Well, they're not. So I would say example 2 is not accurate and is not precise. But if I look at example 1 and you look at example 1, we might not agree on this. I think we agree on they're not accurate, but are they close to each other? They're certainly closer to each other than the darts in example 2, but are they really close to each other? Maybe, maybe not. That leads to an important thing for us to recognize in terms of precision, is that feels like maybe it's an opinion question when it's really not. So remember when I asked you if you would rather be accurate or precise? You want to be accurate, okay? Now, what does this look like? What does accuracy and precision look like in an actual lab or science classroom? Well, here's an example of something you might be asked to evaluate. You might be asked to measure some things and then calculate or determine your own accuracy and precision. So 2 students were given a sample of copper and they were asked to measure its density 3 different times. and then compare what they got to the accepted value of 8.94 grams per milliliter. So the target, the bullseye, is 8.94 grams. And what we're trying to see is how close are students 1 and 2 to the target. That would answer accuracy. So maybe we could look at it like this. Let's say 8.94 is my accepted value. And I'm going to make student 1 red, and I'll make student 2 yellow. How close is student 1's measurements to the target, 8.94? We're measuring accuracy, right? Well, student 1 in red had a 7.3, so that might be down here below the value. They had a 9.4, which is probably somewhere up here, and they had an 8.3, which is probably somewhere in there. If we contrast that with student 2, they had an 8.4, they had an 8.8, getting even closer to the target, and they had an 8.0. And if we do something like this, then we're able to answer the question a little bit better. So let's talk about terms of accuracy. Except I should attempt to spell it correctly. Accuracy and precision. Okay? Let's look at student number 1. All right, let's look at our student red. Accuracy. Student 1, student 1. Was student 1 accurate? Were those measurements close to the target? Well, 9.4 is a gram heavier. 8.3 is almost more than half a gram less, and 7.3 is way off. So we'd say no. Student 1 was not accurate. Was student 1 precise? Were these 3 measurements close to each other? No. Again, they're not. But if we look at student 2 and we evaluate for accuracy, are those measurements close to the target? Well, yeah, they're a lot closer than student 1. And if we evaluate them for precision, how close are they to each other? I'd say they're also pretty precise. So this again drives home the point that you can be precise and not accurate. You can be accurate, and if you're accurate, you're probably also precise. Use this as many times, as often as you need to complete the short section Google form on accuracy and precision.